All right, we're going to talk about 1.6 linear equation inequalities and their applications. So, um, to understand 1.6, we have to talk about sets because when we start getting into two sets of inequalities, we have to understand the difference between an intersection and a union. So we have to get into some set theory here. So say we have two sets. These are sets A, 1, 2, 3, and B, 2, 3, 4. Okay, a set of all elements that belongs to both A and B, called their intersection and symbolized A intersection B, is given by A intersection B equals 2 and 3. So it's what they both have in common, okay? So anytime we talk about intersection, we're talking about what they both have in common. We take just what they have in common, okay? The set of all elements that belongs to either A or B, called their union, and symbolized A union B, is given by A union B, and we take everything. Okay, so if you look here for the intersection, okay, what they share 2 and 3. So that's why the new set was just 2 and 3. But if we wanted to find the union, okay, we take everything. So 1, 2, 3, no repeats, and 4. And so that's why that became 1, 2, 3, and 4. So we're going to use that idea with inequalities. Okay, so a compound inequality consists of two inequalities linked by a consecutive word such as and or. So when we see and, we need to think intersection. Okay. Okay, and we're going to take what's in common. And with or, we're going to think union, and we're going to take everything. Okay, so let's talk about ands first. Step one, okay, is to solve the inequalities individually. Okay, and then we will graph the inequalities, find what is in common, and then write the commonality in interval notation. Okay? All right, so here we go. Example 1. X plus 3 is less than 1 and, okay, so intersection, x minus 4 is greater than negative 12. So x plus 3 is less than 1. We're going to solve. So x is less than negative 2. X minus 4 is greater than negative 12. So x is greater than negative 8. I didn't show my work. Okay, so I got two different things going on here. So here we go. We're going to graph them on the same graph, though. I'm going to use two different colors. So let me start with black. So I've got negative 2. Let me go ahead and put a 0 here. Yeah, that's not going to matter too much. So let's not do that. I've got negative 2, negative 8. So negative 8 is less than negative 2. There we go. So on one side it says x is less than negative 2. So from what we learned before, we've got an open circle. It's going to be less than negative 2. Okay, so I took it all on that side, okay? But then our other inequality says x is greater than negative 8. Okay, maybe I should use a different color since the line's purple. Let's use yellow. Here we go. Still a horrible color, but we're going to go with it. Okay, so I want to take where the black and the yellow intersect as my answer. So let's do a new line here. I'm going to show you the final answer here. So if I look on this line, I have yellow and black here, but I can't include negative 8 because there's no equal to under that line. So negative 8 is just going to be an open circle. I've got black and yellow in the middle, another open circle, and negative 2, and then just yellow off to the side. So this is my final answer. Okay, I took the intersection, what they have in common. Okay, and so my answer in interval notation is going to be -8 comma -2. Okay, again, this is my answer. Okay, just so we know where to stop. A lot of times you struggle with where do I stop, and so this was step 1, this was step 2, step 3, and then step 4. Okay, so let's do some more. So these are just graphing, okay, so that we can practice graphing. So why do I have graphing here? Oh, we already did this. I meant to take this out. So we do not need to do this because we graphed on our last set of notes. So just make sure you've watched 1.5 notes. We graphed a lot. So I think this was just like a review on graphing. Okay. All right. So here we go. Oh, Mrs. Weddington's not very smart. This was to go here and to help you. It's all good. I should know how I write my notes. All right, here we go. So do the same thing. 2x less than or equal to 4x plus 8. 3x greater than or equal to -9. All right, so we're going to solve each inequality. Move your variable on the left over to the right. -2x is less than or equal to -8. Divide by -2. I divided by a negative, so I'm going to switch my sign. Okay, divide by 3. X is greater than or equal to -3. Okay, that was step 1. Step 2, number line. Put both numbers on the number line. So -4, close circle, greater than, and then I have x is greater than or equal to -3. Okay, so I want what's in common. So what's in common is from -3 on. So my answer is going to be starting at -3, close circle, going to the right. Okay, that's my final graph. And then my final answer is going to be bracket -3 to infinity. Okay, I can't include this part because there's not pink and blue. Okay, that happens. All right. Okay, let's do another one. So x plus 2 greater than 3 and 2x plus 1 less than -3. So subtract 2, x is greater than 1, 2x is less than -4, divide by 2, x is less than -2. By the way, guys, if I ever make a mistake and I just breeze past it, please send me an email and tell me, hey, Miss Weddington, at such and such minutes, you made this mistake, just so I can tell you guys I'm not perfect. So sometimes that happens. So here we go. Let's do this. So I've got -2 and I've got 1. So I've got x is less than -2 and x is greater than 1. So I want to take what's in common. Well, there's nothing overlapping. So therefore, there is no solution. Okay. We could also call that empty set. This is a signal for empty set. And then I also see on a test, sometimes they just do a blank graph. That caught some of my students off guard on a final. Okay, they just had a graph and there was nothing there. Okay. All right. So now let's do ORs. ORs work the same way. Okay. We're going to solve each inequality individually, graph the solutions, but then we're going to take everything, or the union, and then we're going to write in interval notation. Okay? All right, here we go. 6x minus 4 is less than 2x. Now this time the x is on the right, so I need to go ahead and move the negative, or move the 6 over. Then divide by negative 4, so I'm dividing by a negative, so x is less than 1. Okay? If you don't like how that looks and you really like the x on the left, switch it around, make it x is less than 1. Okay? Just make sure when you flip it, okay, you change the sign. That's totally fine. Okay? All right, next one, negative 3x is less than or equal to negative 9. Divide by negative 3. Dividing by negative, x is greater than or equal to 3. Okay, so I've got 1, I've got 3. Get rid of this obnoxious pink color. X is less than 1, or x is greater than or equal to 3. Okay, to or, to union, I'm just going to take everything. So I read the entire chart. Okay, so I get, oh, there's no bracket. Choo-choo train star at the left, negative infinity, comma, 1. Now, in this one, we're going to make a stop. Okay, and since I have this gap, okay, I call this gap union station. Okay, so we're going to put a U, and we do need that U because we have a union. Okay, and then we're going to put a bracket because we have a closed circle, 3, 2, infinity. Okay, so this is where we start using the unions, all right, where we have that gap and we kind of stop at one place and then we pick up at another, okay? And that union is important to know that this was an or problem where we started, okay? All right, let's do another one. So I divided by a negative, so x is less than or equal to negative 2. 5x less than or equal to negative 15. Divide by 5, divide by 5, x is less than or equal to negative 3. I did not divide by negative, okay? Even though the answer is negative. All right, here we go. So negative 3 goes over here, negative 2 goes over here. I've got that x is less than or equal to negative 3, and x is less than or equal to negative 2. Okay, I should have done different color, right? We've been doing that, so let's keep it consistent. Less than or equal to negative 2. Okay, again, it's an or. I'm just going to take everything, okay? So I want the whole entire chart. So when I write this, okay, or this one might be easy if I go ahead and do another one. If I want the whole thing, I want all of this all the way up to negative 2. That would be the simplest form. There's no need to stop at negative 3 because negative 2, this inequality includes this inequality. Okay, so the simplest form of these two is this. So the simplest would be negative infinity to negative 2. Okay, all right. All right, last one. Here we go. Negative 2x plus 5 greater than or equal to 11. Subtract 5. Negative 2x greater than or equal to 6. X is less than or equal to, ooh, I divided by negative, almost didn't catch it, less than or equal to negative 3. All right, 4x minus 7 greater than or equal to negative 27. Add 7. 4x greater than or equal to negative 20 divided by 4. X is a greater than or equal to negative 5. All right, here we go. So negative 5, I really like my negative numbers, obviously. Here, we got all negative numbers. We only have one positive number. So I've got x is less than or equal to negative 3. And then I've got x is greater than or equal to negative 5. Okay, well, I want everything. Well, from the looks of this, It just goes on and on and on and on and on, right? So if it goes on and on and on and on, if I were to combine these two, um, starting at negative infinity, it's going all the way through to positive infinity. So that's exactly my answer. Negative infinity to positive infinity. Okay? You've also known this as all real numbers. Okay? All right. Okay, that's 1.6.